Hello student, today I am going to start another module of industrial electronics. This is phase control rectifier. Actually this is our second module. Okay, so today I am going to start this phase control rectifier module. Okay, so let's start our discussion. Okay, so you people are studying various types of semiconductor devices. So you have studied or will be studied SCR, like SCR. SCR means silicon control rectifier, thyristor, power MOSFET, power BJT, diodes, rectifier diodes, then Zener diode. Okay, so these different types of diodes you have already studied, and in first module you will be study SCR thyristor family. Okay, so these devices you will be study in your first module. Okay, so all these devices have different semiconductor characteristics depending on the doping concentration. We see diode is a uncontrolled device. Here the name given as controlled rectifier. So that means rectifier is going to study in this topic. They are going to be different. Okay, so in this topic we are studying rectifier. Okay, so we see what are the devices and why they are known as controlled devices. Okay, so see, rectification. What is rectification? So rectification is a process of converting AC voltage or current to DC voltage or current. Many industrial applications require controllable DC power. Okay, so unlike diode rectifier, phase control rectifier or phase control rectifiers has an advantage of regulating the output voltage. The diode rectifiers are termed as uncontrolled rectifier. When these diodes are switched with thyristor, then it becomes phase control rectifier. The output voltage can be regulated by changing the firing angle of the thyristor. The main application of these rectifiers is involved in speed control of DC motor. So basically rectifier we have studied by using a diode. Okay, but here in this control rectifier or in this module we are going to study rectifier by using SCR, that means silicon control rectifier. Okay, because SCR is a control device, because SCR is a control device and this device can be controlled. If you compare SCR with diode, diode is an uncontrolled device. Okay, so unlike diode rectifier, phase control rectifiers or phase control rectifiers has an advantage of regulating the output voltage. The diode rectifiers are termed as uncontrolled rectifiers. When these diodes are switched with thyristor, then it becomes phase control rectifier. The output voltage can be regulated by changing the firing angle of the thyristor. Okay, so what is the exact definition of phase control rectifier? So the term phase control rectifier is a one type of rectifier circuit in which the diodes are switched by thyristor or SCR. SCR means silicon control rectifier. Whereas the diodes offer no control over the output voltage. The thyristor can be used to differ the output voltage by adjusting the firing angle or delay. A phase control thyristor is activated by applying a short pulse to its gate terminal, and it is deactivated due to line communication or natural. In case of heavy inductive load, it is deactivated by firing another thyristor of the rectifier during the negative half cycle of input voltage. So basically, when we convert one form of energy into the another form of energy, as an example AC to DC, we know the device which convert this AC to DC, a converter. Okay, and this converter is designed with diode. See the first diagram. Here we convert AC to DC by using diode. Okay, so when we use diode, we cannot control the operation of diode. Either the diode will be forward bias or it will be a reverse bias. Or we see some power semiconductor devices as inverters. Okay, so inverters are nothing but the conversion of energy one form to another form, like DC to AC. Basically, the conversion from AC to DC or AC to AC, when to have some devices which will control this energy from one to another form, and it will control the power that can be distributed to load connected to this particular device. Okay, so in this chapter or in this module, we will see how this controlling mechanism can be done. Okay, so the rest part of this lecture I will continue in the next lecture.